because this reaction, we are trying to study the kinetics. So kinetics is very low, right? So right at the beginning of our title of the experiment, Rate laws and reaction mechanisms. So that's our subject. All right. So rate law of this reaction would be what? So change of the peroxide disulfate and change of time. That's your rate of reaction. So this is reaction. Of course, we can have the iodine or iodine or any or all. So we can do all or any. But let's say we pick this one, peroxide disulfate. So rate of reaction is equal to what? Can someone tell me? Equal to what? Concentration, right? Concentration of what? Of your reactant. So rate law is always your rate of reaction, how fast you can have your reaction. It's always concentration dependent. Yeah? So it's always concentration dependent to some power, to some order. So we call order of reaction. So it could be 0, could be 1, could be 2, could be half, could be inverse, you know. And what? And a rate constant. Because we say concentration and rate are in proportion. But as soon as we change from the proportion to the equal sign, we need a constant. So we call rate constant. Yeah? And this rate constant, I know I gave up. How we write the rate constant in simple should be lowercase cursive k. I know. If people write this, I don't really like it. But even when we type it on the computer, it's not easy to find cursive because that K can be very trouble. What's the K? That could be because you know, capital and lowercase is the same thing. You see what I mean? And this K can be many things. Can be equilibrium constant, can be Kelvin, can be even what? Potassium, you know. Of course, this one, cursive K can be many things too, but so far we use it for rate constant. Okay, so if you do handwriting, do lowercase cursive K. Can we do that? I know when you type, it's not easy to find that. But anyway, yes, this is really a constant. Constant like gravity, for example. Constant like speed of light. Yes or no? No. But we say constant. What can make it different? I say, you know, so this one would be temperature. So temperature dependent. So if you change the temperature or at different temperature, then you have different rate constant. So if you have temperature at 298 Kelvin, so you have a rate constant. If you have 308, so you have another rate constant. So different temperature, you have different rate constant. Yes. So let's take a look at one by one, all right? So do we know this? Do we know this? So this is the initial. So we refer to initial because the approach or the technique we use is using initial method. So the concentration of peroxide disulfide and iodide, those are initial concentration. Because it's initial concentration, that is because you make whatever concentration for your reaction. So you do it, so you know it. So we know this. Do we know the rate constant? No. Do we know the reaction order? No. So we have 3 unknown. Do we know the time? Yeah, because that's your data. Yeah, that's your data, or time data, I should say. How much time to get it blue? Now, because how much time to get it blue, so do we know this? So we just said it. So this, the change, now do not get confused between change of peroxide disulfide and initial concentration of peroxide disulfide. So this is what you have at the beginning. This one is how much you use up correspond to that time. You got me? So how much peroxide disulfide you have used correspond that much time. So do not get it mixed. Now of course this one is equal to half of thiosulfate. So we talk about the stoichiometry between the thiosulfate and iodine, and the iodine and peroxide disulfate is 1:1. So this one is half of the thiosulfate. But anyway, for this equation, we have 3 unknown. So we have K, and then reaction order with respect to peroxide disulfate and iodide. So we have 3 unknown. Can we solve the algebra? We cannot do that. So therefore we need what? 3 equations, 3 unknown, right? That's the algebra. So therefore, how many reactions we have? How many reactions? I can keep asking. How many reactions we had? 3, yes? We have 3 reactions, 3 mixes. So that's why we have 3 reactions. Not 1, not 2, but 3. Why 3? Because we have 3 unknowns. Are we good?